Hello everyone. So, me and Anuj will be briefing you about the wave propagation in colonization of Mars. So, first of all, I'd like to tell you about what is an EM wave and how does it propagate. Electromagnetic waves are waves created as a result of vibrations between varying magnetic and electric field. An EM wave propagation is the way in which EM wave travels through vacuum or a material medium. So when the EM wave travel through the material medium, the speed is slightly lesser than to that of when the EM wave travels through the vacuum. So an EM wave is also a transverse wave, which is a wave in which the oscillation is perpendicular to the direction of the wave. So the next up, we have the electromagnetic spectrum, which spectrum is the range of frequencies of electromagnetic radiation and their respective wavelengths. So this spectrum covers the frequencies ranging below 1 hertz to above 10 to the power 25 hertz. As you can see, it consists of various radio waves that, for example, gamma rays, X-rays, ultraviolet, visible light, and so on. So the next up we have is the types or the methods of EM wave propagation. So the first up is the ground wave propagation. So it is also known as the surface wave, which is a type of radio wave propagation in which waves propagate uh, over Earth's surface in low or medium frequencies. Basically, it is used for a low frequency range transmission, mostly less than 1 megahertz. The second one is the sky wave propagation. Uh, it is also known as the skip, in which waves are either reflected or refracted back to the Earth from ionosphere, which is an electrically charged layer of the upper atmosphere. So basically, this type of wave propagation is used for uh, waves with a frequency range from 3 to 30 megahertz. So the third one is the space wave propagation. So this method is also known as the tropospheric propagation, as the waves can travel directly from the Earth's surface to the troposphere surface of the Earth. So basically, it occurs within 20 kilometer of the atmosphere, and it is used for line of sight communication, or the LOS. So space satellite communication and very high frequency waves use this propagation method. So next up, we'll understand about Mars and related similarities to the Earth. So the first one, where goes the duration of the Martian day is close to that of Earth, which consists about 24 hours, 39 minutes, and 35.244 seconds. The second one is that observations by NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and NASA's Phoenix lander confirm the presence of water ice on Mars, which can be a crucial link in future for our wave propagation in that colonization of Mars. So the third one, that Mars has an axial tilt of 25.19 degrees, which is similar to that of Earth's 23.44 degrees. That means that Mars also has seasons like Earth, but they last almost twice, because a Martian year is about 1.88 to that of Earth year. So next up, I'd like to invite my partner Anuj to brief you further. Thank you.
Hello everyone. Now we shall look into some differences between Earth and Mars. So the first point is gravity at Earth and Mars is very different. Martian gravity is only 38% to that of Earth's gravity. That is 3.721 meter per square second, which suggests that gravitational force offered by Mars is far less than Earth. Now second point is the Martian atmosphere is also very thin compared to that of Earth, and hence the atmospheric pressure is very less, which is about 6.518 millibars on Mars compared to that of Earth, which is 1.01325 bars. So there will be a need of pressurized suits for people or astronauts when they go there for further studies. Also, the air is highly toxic, which consists mostly of carbon dioxide, about 95%, and oxygen present in the atmosphere is very less, which is less than 0.4% of the total atmosphere. Additionally, 3% nitrogen and argon, 1.6% is also present in the Martian atmosphere. Now, the third point is water is very scarce in Mars, and and since we are looking to explore Mars, and in future we are looking to colonize Mars, so it is very important to have a source of water for us. Average temperature at Mars is also very low, which is about minus 81 degree Fahrenheit or minus 62 degrees Celsius, and it does not rain off Mars. And the fourth point is the Martian soil is highly toxic, having mostly high concentrations of chlorine and associated compounds, which are hazardous to the most known life forms. Vinayak, please next slide. Now, since the ionosphere plays a major role in radio wave communication at Earth, it also plays a role in radio wave communication on the Martian surface. So let's look at that. So the first point is the Martian ionosphere is complex as compared to that of Earth's ionosphere, and it extends from about 100 kilometers to several hundred kilometers for, from the Martian surface. Also, the thickness of ionosphere varies a lot. Due to the presence of very weak magnetic field, Martian ionosphere directly interacts with the solar wind particles, extreme UV radiations, and X-rays directly from the sun. This plays a major role in ionization of the ionosphere. The ionosphere is weakly ionized on the Martian surface of Mars, and the highest ion density is found at about 140 kilometers from the ground, which is charged by the UV radiation from the sun. And day side of ionosphere of Mars is better for radio wave communication as compared to the night side, as ions get charged in day side easily because of the UV radiation. When next, please next slide. Now, next slide is about EM waves propagation on Mars. The day side ionosphere can be used for low frequency communication, as low frequency communication can travel larger distances, and the hindrance caused by the Martian atmosphere is less. So it can be used for future exploration. Extremely low frequency communication can be done on the planet. Extremely low frequency signals can travel long distance on the curvature of Mars. Ground wave propagation for communication within the planet can be used using extremely low frequency waves for carrying signal. A large area can be covered with just one signal system, and rovers on Mars can work more on more remote areas. Fourth point is for sending data to Earth, rovers use ultra high frequency antenna to transmit data back to the orbiters, which transmit back it to the Earth. Ultra high frequency signals are used because they can penetrate the Martian ionosphere very easily, and as it is very thin. So, Vinayak, please next slide. Now let's look at our last slide. So here we talk about how are EM waves helpful in colonization of Mars. We see that low frequency radio waves can be used for communication, just like we use here on Earth. We use spectrometers, which takes light waves and detect the kind of material in the surroundings, and it has helped us understand the atmosphere of Mars from so far away. As discussed earlier, extremely low frequency signals can be used for communication by early astronauts who will go there, and the data received from NASA rovers has helped greatly understand the surface of Mars. And all these features and factors in which EM waves are used for different studies done on Mars has helped us better understand the red planet. There are still many challenges to overcome. The weather is not consistent there, and storms are you can't say when they will stop and when they can come. But still, one day it would we will see that the use of EM waves would have played a major role in colonization of Mars. So now I would like to conclude our presentation and thank each and every one of you and our mentor, Dr. Sudhir Chaturvedi sir. And we thank you for your patience. And for hearing what we had to say. Thank you very much.